The data in this table represents the number of corn plants in a randomly sampled rows, a 17-foot by 5-inch strip for various types of plots. An agricultural researcher wants to know whether the mean number of plants for each plot type are equal. Okay, so for this, we first want the null and alternative hypotheses for our ANOVA test. The null hypothesis is going to be that the mean of all three of these are equal. So the mean of the sludge plot, mean of the spring disk, and mean of the no-till. All three of those are equal. So this is mean 1 is equal to mean 2 is equal to mean 3. So this is referred to as 1, 2, and 3. The alternative hypothesis and actually let me be consistent when I write this. The alternative hypothesis is that at least one of these means is different. So at least one mean is different. What that just means is the null hypothesis says all three of them are equal. The alternative is that any one of those three is different. Doesn't matter which one, and there are ways to determine which one it is. But for this ANOVA test, we're just trying to find if one of these is different. So I have this data in this Excel document on here. But I'm going to need to type this one in because of the way it's formatted. So we have here 25, 27, 33, 30, 28, and 27. For the sludge plot, the spring disk was 32, 30, 33, 35, 34, and 34. Then for the third one, the no-till one, this is 30, 26, 29, 32, 25, and 29. Okay? So, putting that into Excel on here, we have our data summary, which shows these different values. We have a ratio of standard deviations of 1.57, which is nice. We'll get back to this calculation tab on the last part on here. But for the requirements, we have a bunch of requirements that we need here. The first and foremost being that this is a simple random sample. Simple random. And we were told here that this is indeed a random sample. So yes, that assumption's met. We need that the mean of each sample must be assumed to be normal. We wouldn't really know that unless we were told it. Nothing in here specifically states them to be normal, so we're just going to assume that. The standard deviations being equal, the standard deviations being equal, again, we're not really told what they were. But if we look inside this data summary tab, we had a ratio of standard deviations of 1.57. As long as that number is less than 2, then the standard deviations would be pretty close to each other. And we could see that these three standard deviations, I mean, there's a little bit of variation, right? This one being at 1.79. the difference between the highest and the lowest being almost 1. So there's a little bit of variation there. But because this ratio is less than 2, we could indeed say this. So I'm going to write here ratio less than 2. So we're good there. And the last one that we need was that the total sample size must be at least 40. Well, we need each sample itself to be at least 5. Each of these has a total of 6 in it. So each sample is greater than 5. And because of that, we have a total of 6 here. 3 of these. We have a total sample size of 18. Now 18 is less than 40, but it is at the very least greater than 15. Since we're assuming these to be normal, we could say that the normality then with this being 18 then is also met. Now for the hypothesis test, so this calc tab, we can add an F value on F test statistic of 7.10 and a P value of 0.0068. Alright, 0.0068. And we could write out this this conclusion. This would be at the 5% level of significance, we have sufficient evidence to claim that at least one of the means is different. Again, we technically do not know which one due to the fact that this doesn't really tell us which one. Mind you, if we looked at the data summary tab, we could tell that this middle dataset 2, which corresponds to the spring disk, that has the highest mean on here. Could it likely be that one? Potentially, but we don't really know based just upon this. There are other methods that could tell us which mean is indeed the greatest out of all of them, but that is outside of the confines of this class.